Imagine a world where the ground beneath your feet is a ticking time bomb. A world where temperatures plummet to a bone-chilling minus 80 degrees Celsius. This isn't a science fiction movie. It's the reality for engineers working in the Arctic. A place where building anything is a monumental battle against nature itself. Today, we re-journeying to the frozen frontiers of our planet to uncover the incredible story of how we build in one of the most hostile environments on Earth. Here, the biggest challenge isn't just the cold. It's something hidden, something constantly shifting, and something incredibly powerful. Permafrost. So, what exactly is permafrost? Think of it as a giant, underground block of ice, soil, rock, and organic matter that has remained frozen for at least 2 consecutive years. In some parts of the Arctic, this frozen layer has been solid for thousands of years, extending hundreds of meters deep. It sounds stable, right? A solid, frozen foundation to build on? Well, that's where the problem begins. The moment you introduce heat, everything changes. Every building we construct, every road we lay, every pipeline we install generates heat. Even the simple act of clearing away the insulating layer of snow and vegetation can be enough to start a catastrophic chain reaction. As the permafrost begins to thaw, it's like pulling the plug on a sink full of mud. The solid ground turns into a soupy, unstable mess. Buildings start to tilt and crack. Roads buckle and warp, and entire structures can sink into the earth. It's a silent, slow-motion disaster. Engineers in the Arctic aren't just builders. They're warriors in a constant fight against thermodynamics. Their enemy is an invisible force, and their battleground is the very land they're trying to develop. So, how do they do it? How do you build a city on what is essentially a giant ice cube? The answer lies in some of the most ingenious engineering solutions ever devised. One of the primary strategies is to keep the permafrost frozen at all costs. You can't just lay a foundation on the ground like you would in a temperate climate. Instead, many Arctic buildings are constructed on stilts, or piles. These piles are driven deep into the permafrost, sometimes dozens of meters down. By elevating the building, air can circulate underneath, creating a buffer that prevents the structure's heat from ever reaching the sensitive ground below. It's like putting the entire building on life support, with the cold Arctic air as its medicine. But what about bigger structures, like airports or massive industrial facilities? You can't put an entire runway on stilts. This is where things get even more futuristic. Engineers use a technology called These are fascinating, self-regulating devices that act like a one-way heat pump for the ground. Picture a long, sealed tube filled with a special refrigerant gas. The bottom of the tube is buried deep in the permafrost, while the top is exposed to the frigid winter air. During the winter, the cold air cools the gas at the top of the tube, causing it to condense and sink. As it sinks, it absorbs heat from the ground, causing the liquid to turn back into a gas and rise again. This continuous cycle effectively pulls heat out of the ground all winter long, super chilling the permafrost and ensuring it stays rock solid, even under the weight of a jumbo jet. In Tesumer, the process automatically stops, so no heat is transferred back into the ground. It's a passive, brilliant system that uses the Arctic's own cold to fight the thaw. Building roads is another massive headache. A dark asphalt road absorbs sunlight, heating up and melting the permafrost beneath it. The result is a roller coaster-like road surface that's dangerous and constantly in need of repair. To combat TS, engineers have developed white roads. They use lighter colored aggregates or even paint the surface white to reflect sunlight and keep the ground temperature stable. They also build roads on top of thick gravel pads, sometimes several meters high, which act as a massive layer of insulation between the road surface and the permafrost. These aren't just theoretical concepts. These are real-world solutions being deployed right now in places like Yakutsk in Siberia, often called the coldest city on Earth, and across the northern territories of Canada and Alaska. In these places, a sagging door or a crack in the wall isn't just a sign of a settling house. It's a warning that the ground itself is giving way. However, a new and urgent challenge is emerging. Climate change. As global temperatures rise, the Arctic is warming at more than twice the rate of the rest of the planet. The permafrost that was once considered permanently frozen is now thawing at an alarming rate, independent of any construction. This isn't just a problem for future buildings. It's a threat to existing infrastructure that was built decades ago, designed for a colder, more stable world. Entire communities are now at risk. In some coastal villages, in Alaska, the thawing permafrost is causing the coastline to erode so quickly that entire towns are being forced to relocate. The cost is astronomical, both financially and culturally. It's a slow-motion crisis unfolding at the top of the world. This thaw is also releasing a climate time bomb. Permafrost holds vast amounts of ancient, frozen organic matter. As it thaws and decomposes, it releases massive quantities of carbon dioxide and methane, potent greenhouse gases that will further accelerate global warming. It's a dangerous feedback loop, and the engineers on the front lines are in a race against time to adapt. The next generation of Arctic engineering is focused on resilience and adaptation. They're developing new materials, smarter monitoring systems with sensors that provide real-time data on ground temperature and stability, and flexible designs that can adapt to a changing landscape. They are pioneers, writing the rulebook as they go, because the ground rules literally are changing beneath their feet. The work of these Arctic engineers is a testament to human ingenuity in the face of incredible odds. They are battling extreme cold, invisible forces, and a rapidly changing climate to build and maintain the lifelines of the North. Their success or failure has implications for us all. The stability of the Arctic is directly linked to the stability of the global climate. So the next time you see a picture of a building on stilts in a snowy landscape, remember the incredible science and sheer determination that went into it. It's more than just a structure. It is a symbol of our struggle to coexist with one of the most powerful and fragile environments on our planet. It's a story of ice, steel, and the relentless human spirit. Thanks for watching. If you found this journey to the frozen North fascinating, don't forget to like this video and subscribe to our channel for more stories from the frontiers of science and engineering. See you next time.